Now let's discuss the last of the traditional five senses, touch. Also called tactile perception, the sense of touch is not actually one sensory system, but rather comprised of several sensory modalities, including pressure, skin stretch, vibration, and temperature. Thus, while it's considered one of the five classic senses, the term touch in medicine and science is often replaced by the term somatosensory to better reflect the many mechanisms involved. The somatosensory system is a rather complex sensory system made up of a number of different receptors and receptor types, including thermoreceptors, photoreceptors, mechanoreceptors, and chemoreceptors. Further, the term also includes the essential sensory modalities or processing centers needed to perceive input from these receptors, such as proprioception, mechanoreception, thermoception, and nociception. These describe our ability to sense body movement, touch, temperature, and pain, respectively. The somatosensory system is also distinct from our other four traditional senses in that its sensory receptors are not localized to a specific organ, such as the eye, ear, tongue, or nose. Instead, the sensory receptors of the somatosensory system cover our skin and epithelial tissues, our skeletal muscles, our bones and joints, and our internal as well as cardiovascular organs. Touch, pressure, heat, cold, and pain are together known as the cutaneous sensations, but they're actually picked up by different sensory neurons and different mechanisms. First, let's consider heat, cold, and pain, which are sensed by naked nerve endings in the skin. There, these sensations are picked up by transient receptor potential channels, or TRP, TRP channels. TRP channels are a group of ion channels located in the plasma membrane of numerous human cell types, where they mediate a variety of sensations, including pressure, volume, stretch, vibration, and even certain tastes. In the human body, when sensing heat or cold, TRP channels are thought to work like tiny thermometers. Perhaps not surprisingly, these channels are also sensitive to certain chemical ligands we often perceive as either hot or spicy or cooling. Some hot-sensitive TRP channels are activated by molecules found in spices like garlic, chili pepper, or wasabi. Others are activated by substances like menthol, camphor, or peppermint, thus mediating a cooling sensation. Let's take a look at how these channels work at a molecular level. They're in fact relatively simple. Most TRP channels are non-selectively permeable to cations, including sodium, calcium, and magnesium, and thus can depolarize and activate a sensory neuron when stimulated. Curiously, there appear to be more cold-sensing receptors in the human body than heat-sensing receptors, and the latter are generally found deeper in the layers of the skin. Temperature can either inhibit or excite each receptor type by mechanisms that aren't yet fully understood. Next, we have pain sensation, or nociception, which is mediated by specific sensory neurons called nociceptors via free nerve endings that respond to tissue damage. Such tissue damage can be induced by intense chemical, mechanical, or thermal stimulation. For example, think of chili powder in your eyes, or pinching your skin, or touching something really hot or really cold. Once stimulated, a pain sensory neuron sends a signal along a cascade of myelinated or non-myelinated nerve fibers via the spinal cord to the brain, where appropriate motor responses and movements are triggered. Since nociceptive neurons generate trains of action potentials in response to intense stimuli, their firing frequency determines the intensity of the pain. Lastly, our sense of touch emerges from specific mechanoreceptors that respond to mechanical pressure or distortion. In humans and most animals, these receptors differ based on whether or not the touch is perceived via hairless or hairy skin. Hairless or glabrous skin contains four types of mechanoreceptors: Pacinian corpuscles, Meissner's corpuscles, Merkel's discs, and Ruffini endings. We don't need to go into the details here about how each of these receptors work, but suffice it to say each receptor type provides information on different features of your skin's interaction with the outside world, including pressure, position, and features such as the shape or edges of an object. Mechanoreceptors are also found in hairy skin, where naked nerve endings are wrapped around the hair follicles and sense distortion of the hair as a result of tactile perception.